Okay, so this particular one here, given the following code, which of the constructors shown in the options can be added to class B without causing compilation to fail? Okay, now this will test your knowledge of the no argument constructor and the insertion of super into subtype constructors. We want no compiler error. Okay, note here you have a constructor that takes in an int up here, so you cannot have super been called. You need that one, that's fine, that'll call it, but the compiler will put in the super round brackets if there is no super, but there is a super there, so this is okay. But it wants to know what else can we put in here. Showing the options can be added to class B. So there's one that takes in 2 ints. Can we put in one with no arguments? Can we put 1 int? There's another one with 1 int. There's another 1 int, and so on. So the first one here, that's no arguments. It's nothing in here. It's going to put in super, round brackets. And there is no super. There's no A with round brackets. There's no argument constructor up here in A. The only time the no argument constructor, the default constructor, gets put in by the compiler is when there's no constructor present at all. And there's one here, therefore it won't be put in. Therefore, that will not work. Failure to compile. This one, what's the first line of code? Is it a call to this? Is it a call to super? No, nothing there at all. Therefore, super round brackets gets inserted in there as well. That's not going to work. Here, we do have a call to super, and it's going to call this one. Nothing wrong with that. This next one, what's the first line of code? There's no call to this, there's no call to super, so it puts in the super round brackets. That's a problem again, for the same reason that that was a problem and that was a problem. Okay. The last one then is a call to this with 2 int arguments, because Z is an int. So we're in B and we're making a call to the constructor which takes 2 arguments in B, that one. And that one calls super up here, so this one's okay. So if I evaluate that, we're fine. It's worth reading some of this. Further, the parts inherited from the super class need to be initialized first because the subclass may depend on them. And that's why the construction has to go to the top and work its way out. Super all the way out. Then the next paragraph. Now, if the superclass, which means class A in this question, does not have a no args constructor, the call to super, that there, will fail. Hence, choices B, well, these guys here, that one, and that one are not valid because these constructors do not explicitly invoke the superclass's constructor, and the compiler automatically inserts a call to super in them. But A does not have a no args constructor. And then point 2, instead of calling a superclass's constructor using super with the arguments or nothing at all, you can also call another constructor of the subclass in the first line. In other words, something like that. This. The first line of this constructor is a call to this with 2 ints, which causes the B with 2 ints to invoke, and B calls super. So the superclass of A is correctly instantiated before the subclass of B begins initialization. So to repeat, the first line of a constructor is a call to super or a call to this. Okay, so if it sees a call to this, it will not insert super there because both of them have to be the first line. There can be only one. Okay, but there it sees nothing, so it puts in super, sees nothing, puts in super, sees nothing, puts in super. So this particular question here is about the order of the static versus the instance initialization. Okay. So what you've got to be careful with here is that this particular fella there is an instance initialization. Okay. Tricky, tricky, tricky. So when main gets loaded up, that's a static method. Okay. So it loads up or gets the static initializations to be called, which is that one there. So that calls SM1 with A. Okay. So therefore A gets printed out. And then this guy is the next static block. So C gets printed out. And when we go in here and we do the init test, that causes the instance initialization, which is that one that I was saying that's very subtly put in there. So B. Okay, so I have just a small program in NetBeans to show you that there. So when I run that, you're going to get the first static block, then the second static block, because main, so main results in A and C. And then when you call the instance, that is when the instance block runs. So it's A, C, and B. So what I'm saying then, if I comment out that guy, you won't see B. There it is. It's gone. Okay. Doesn't load it up. 2.1075. Now, this is a fairly tricky one. Again, you just have to be careful what you're doing. And I actually have it. It might be easier to see, but when you're looking at it like this, I'll show you the errors in NetBeans because it might be a little easier. Question 3. So the first option here is to comment in. So the question there, you're given the following source code. Which lines of code that are commented out may be commented in without making any problems, without any compiler errors? First one is that one. So that is a final method that you're after bringing in here, H, and you're in a subtype and you're trying to override it. Final methods cannot be overridden. So that's why that's a problem. Okay. Number 2 is this one, bringing this constructor in here. That is going to cause a problem with this line, because this line is calling the no argument constructor. Now, if you have no constructor at all, the compiler will synthesize a default one for you. But if you that's because you've none at all. You put one in, it won't do that. Therefore, you have nothing for the no argument constructor now. So that's why that's wrong. The third one is to comment out, comment in that line. Yeah, that's okay. There's no K up there. That's no problem. That's the correct answer. But let's talk about the other ones. Number 4 is to introduce that method, and it's looking to increment a variable called J, and J is private up here. There is no J in the method. There is no J in the outer scope. Is there a J in the parent? Yes, but it's private, so you can't access it. So that's why that's wrong. You don't have access to it. And 0. If we put in an abstract method f up there in the parent, well, the class is abstract. That's not a problem. What about the subtype? The subtype is not abstract. So therefore, it must put in an f method, and it hasn't. So by putting an f up here, it's no impact on the class because the class is abstract. But the subtype either has to be abstract or else provide the method. And it's not doing either. It's not doing either. That all right? So that's that one there. and the kind of things you'd have to be thinking about. Okay, when a class whose members should be accessible only to members of that class is coded such that its members are accessible to other classes, well, that's weak encapsulation. That's what that is, weak encapsulation. Just so you know, weak coupling is that where you know as little as possible about how a method works. So you just pass in the arguments and you get back a return. You don't know how the method works. That's the way you want it to be. And high cohesion is another good thing to have. A class is highly cohesive if it does one job, or a method is highly cohesive if it does one thing. It doesn't do 3 or 4 different things. So usually what you want is weak coupling and high cohesion. They're the 2 things that you would like. And obviously, strong encapsulation as well. So, which of the following are true regarding overloading of a method? Now, overloading is all about the signature of the method name and the arguments. The method name has to be the same, but the argument names or the argument types and their order have to be different. So let's read the first one. An overloading method must have a different parameter list, yes, and the same return type, no, as that of an overloaded. Once you have the different, if you have different arguments, the types, then you're talking about a completely different method. Okay? But they must have a different parameter list, yes, as regards to the types. But the return type, there's no restriction on that. Okay? If there is another method with the same name, but with a different number of arguments in a class, then that method can be called overloaded, yes. Okay? That's what an overloaded means. You have the same name, but you have different argument order or different number of arguments. If there is another method with the same name and same number and type of arguments, but with a different return type and class, then that can be called as overloaded. For overloading, well, let me see now, evaluate that. That's the explanation here. For overloading a method, the signature of the overloaded methods must be different. In simple terms, the signature includes the method name and the number of type of the arguments. So if the parameter lists of the 2 methods with the same name are different, either in number, the terms of the number, or in the numbers of the types, then they are overloaded. For example, method M1 is overloaded if you have 2 methods, M1 with an int and M1 with a double. Or if you have M1 with an int and you have M1 with an int and a double, they're overloaded methods. It's just the name of the method and the types and the order that they appear in. So you could have a M1 with an int and a double and M1 with a double and an int. That's overloaded. The last one, an overloaded method means a method with the same name and the same number and types of arguments that they exist in the superclass and the subclass. Nope, that's overriding as opposed to overloading. Inheritance. But an important line here is note that the return type is not considered part of the method signature. So when you're looking at overloading, forget the return type. Forget about it. If you're overriding, yes, the return type, if it's a primitive, it has to match a long, an int, a double, a float, lowercase letters. Or if it's a type, like object, then it must be an exact same type in the overriding method, or it can be a subtype, covariant, like it could be returning a string in the subtype. Now, here comes one of the beauties. Let's try the document again. We have BAP as the parent and beta as the sub. So there's your BAP, subtype beta. Then I have a int h, which is public, set to 4. That's why I have the h up there. Set to 4. And then I have an instance method called getH. And then I have a h set to 44 in the subtype. And I'm overriding it with the getH. I then come along in main and I say BAP reference B, this guy over here, is assigned new beta. There is the beta. And beta has a h of 44. Okay. Now, I come along here and I output, okay, that's a B that's over there and that's an A over there. Basically what I'm trying to say there is that the method will get done first inside the system.out.println. It has higher precedence than just outputting a simple data item. So what does b.getH do? Well, this is an instance method, so it's the polymorphic method in beta that we're going to be executing. So we go to this version. We say beta, and then we append on h. Now h is essentially this .h, which is basically the h in beta, because that's the object we created, this .h. So it's going to output beta 44 there, that line there. Now, it also returns 44, and that's going to get plugged into the system.out.println. So there's two print lines in that one line there. There's the system.out.println, which is going to, that one there, is going to get done second. Because in the method call, it goes in here, and it does this system.out.println first. So it outputs beta 44. Okay, there's the 44, and then it returns 44, and that return 44 is there. Part of the system.out.println. What's b.h? Well, that's a data item. So b, what's the type of b? Remember, for data items, you check the reference type. It's a BAP. What's h? 4. So you're going to end up with 4, and then a space, and then 44 in that system.out.println, the second one. 4 plus 44. So if I can just squill this down a bit. In the correct answer, you can see the b.getH gives me that first line, beta 44. And then the 44 that's on the second line is what b.getH returns. And then the 4 is from b.h. Okay. Now, what we do next is we downcast the b to beta. This always raises the question, can I not just say beta BB is assigned B? Well, what's B? B is of type BAP. So you're trying to go from reading it right to left, you're trying to go from B, which is a BAP, into a beta. That's coming down the tree. Always think of that. If you're coming down the tree, you need a downcast. Upcasting, you don't need an upcast. You don't need a cast. But when you're coming down, that's why I always call it a downcast. You need a downcast. So you're going from BAP down to beta. B is of type BAP. You're going down to beta. So you need the cast or it won't compile. Will you get a class cast exception at runtime on this right-hand side here? That depends on what that B is referring to. If it's referring to a beta, you're okay. And what are we referring to? Yes, it is a beta. So beta BB is assigned that. That's what you end up with there, that bit there. Okay. Now we call bb.getH. Well, that's going to be calling the getH in beta. We already went through that. We know that's going to give us, see the two arrows are going to the same thing, output that line of code, output that bit, beta 44, and return 44 into this system.out.println. So it's going to be 44 again. But what's bb.getH? BB is of type beta. So I'll put the H in that, which is 44. First time it was b.h. What's b? It's a BAP, so it was 4. Now, however, bb is beta, so I'll put 44. So if I go down here, there's the beta 44, which is coming from the getH method. Okay, it returned 44 the first time, and there's the b.h, 4. So the beta 44 is the b.getH again, or it was bb.getH the second time, because it's referring to the same object all along. The only object created is new beta. So when you call the instance method, you get the instance method from the beta object. So you get beta 44 the first time, you get beta 44 the second time. The getH returns 44 the first time and it returns 44 the second time. See if I can get that there. There's the 44 both times. The only difference is that the first time we were looking at an object of type. The reference was a BAP. The second time, the reference is a beta. And that's why the 4 and the 44 are different. There's the b.h, which is from BAP, and the bb is the one from beta. This particular one, what will happen if the following program is print and run? So you're creating a change test, okay? You're calling show2, passing in 200. So there's show2. It's calling my value. You've got an instance variable, my value set to 0. And we're saying this dot my value is assigned my value. So 200 goes into the object instance variable. Okay. We then go and we output that ct.myValue, which is 200. Now note, we can only refer to the private instance variable using the reference because we're inside in the class. Don't be thinking that you're in another class, you can have an object reference and refer to private data. You can't. That only works. You need it first of all because you're inside static main. If I just said my value, you'd be trying to go from a static context to a private instance variable. An instance variable. Static to private does not work. You need a reference. And that only works, that syntax reference.private variable, that only works because I'm still inside the scope of the class where the private variable is. So the next thing that we do is ct.show1 passing in 100. There's my value. Sorry, show1 is up here. My value. My value is assigned my value. That's shadowing. You've got a local variable, which is the same name as the instance variable. You definitely need to do this. This dot my value is assigned my value if you want to change the instance variable. Because what it'll do is it'll say, okay, here's my value. Is there a variable in this scope called my value? Oh, there is. It's that one there. Grand. I'll assign it to be, is there a local variable or is there a variable in this scope called my value? Yes. So you're just assigning it to itself. And then you hit the curly bracket and you come out of the scope and that variable is gone. So in essence, the effect of that is that the instance variable has not been changed. So you'll end up with, when you output it a second time, 200 followed by 200. So you changed it to 200 successfully there. You did not change it to 100 there. Nothing happened. So I have a value at that. There you go. That okay? All right. What is meant by encapsulation? There is no way to access member variables. That's not right. There are no member variables. Well, that's definitely not right. Member variables are declared private and public access or mutator methods are provided to access and change their values if needed. Yes. Data fields are declared public. No. And access and methods are provided. Okay. That's fair enough. That's an easy one. Given the following definition of class, which member variables are accessible from outside the package? So here we have a package, and then we have a package private I. So we want to figure out which ones are accessible outside. Well, that's not accessible outside, that's package private. Public, absolutely. Protected, yes, in specific circumstances. Private, no. So let's look at the variable k, because you might go along and say, oh yeah, there you go, bang, you're caught. Because it has k there twice. And that's the more correct of the two. Variable k, but only for subclasses, which is correct. So protected means you're accessible within the package and also to subclasses regardless of the package. So the subclasses can be in any package. And that's the answer to that one. Okay. How can you declare I so that it is not visible outside package test? Well, I think that's fairly straightforward. You make it private or you put no access modifier on it. That way it's accessible inside the package only. That all right? Consider the following class. You've got a param test, you've got a method print sum which takes in 2 ints, you've got another print sum which takes in 2 integers, and another print sum which takes in 2 doubles. And you specify a method called print sum 1, 2. So the question is, which one does it go into? Will it go into the int or the integer or the double? And the answer is that it will go into the int because 1 and 2 are ints, which are an exact match. So 1 and 2 are ints and they definitely will go in there. So it will be int 3. Now, what do you think might happen if there was no int method? Well, I have a program to show you that. So I've commented out the int one. Is it going to wrap to an integer or is it going to widen to a double? And this is how you find out by running little programs like this. Interesting. It widens. Widening is preferred to boxing and unboxing. Now, this particular one, given a class named test, which of these would be valid definitions for a constructor for the class? So there's a constructor, same name as the class, no return type. Can I pass in the same type? Yeah, no problem with that. This one is a return type of test. Constructors have the same name as the class and they do not have a return type because the compiler takes care of the return type in the background by putting in the reference. It's done implicitly in the background. Here's one, but a constructor cannot be final, static, or abstract. So it's not private, it's the problem. It can't be final. Now, it doesn't make any sense for it to be final, okay? It's not like you're going to be overriding it anyway, because, you can't override a constructor. If you extend it, you're into a different class name with a different constructor. So final, static, and abstract are the 3 keywords you cannot put on a constructor. You can't have a return type. And as I was saying earlier, you can't, well, both are wrong there, God. Return type and static is wrong for that. Now, why is static wrong? Well, constructors are instance methods. Makes sense. Constructors are used to creating object instances, not a class instance, and static is for class. An abstract, same reason for final. it doesn't make any sense because you're not going to be overriding it anyway. You're not going to be providing an implementation in a subtype, which is what abstract does. Okay, this particular one, you've got data with private int x and y. There's a constructor initializing it, and then we're creating an instance of that data with 1 and 1. Which of the following options, when applied individually, will change the data object currently referred to by the variable d to contain 2 and 2 as values for x and y? Add the following two statements. Can I say that I'm in a different class? I'm using the reference d to access x and y. No, x and y are private. That's what I was saying there about 5 minutes ago. Private variables can't be accessed like that, even though you have a reference. Add the following statement. That's not, it's going to give you a new object completely. What we want to do is change what d is currently. Add the following statement. D, again, you have the same problems as the first one. Access to private. Add the following method to the data class, which is public set values. And you say this dot x dot set int. That's x is a primitive. It's an int. And primitives don't have methods, so that's wrong. Add the following method. There's your set values x and y. This dot x is sign x, this dot y is sign y, and you call the set values public method with 2 and 2. That's the one. Okay. This particular one here, 2.957, we have a particular test class with static sum int. Now, we're inside the main and we call the method change it with just a direct reference to sum int. That needs to be static for us to do that, and it is. So we make a copy. Everything's called by value in Java. So in this case, we're making a copy of a primitive, which is like making a photocopy of a page. So A is a new primitive that takes on the value of 10. I change the local variable A to 20, which has no effect on sum int. A gets destroyed, we come back and we output the value of sum int, which is 10. Okay? So everything's passed by value, and if it's a primitive, it's like a photocopy of a sheet. They pass the photocopy over, they can do whatever they want to the photocopy, you've still got the original sheet. All right? Which of the following code fragments are valid method declarations? It's missing the round brackets after the 1 there. So, well, I'll evaluate it in a minute and you'll see them all, but void method 1, round brackets, and then the curly brackets. As in the second one, yes, which is the right answer. Correct. There's the round brackets. This one here, void as an argument, no.
It's a keyword.
Keyword, yeah. Now you put them in as a return type when you've no return type at all. That's missing a return type. It's also missing the round brackets. And then again, here's the void in the wrong place. And there's no return type. So let's evaluate that. Keyword void is not a valid type for a parameter. There you're missing the round brackets. And the return type and the method name are always side by side. Remember that. The next one, 2.831. This is similar to the previous one. In fact, there's 2 coming now that are very similar. So in this case, we're creating a change test, and then we have show 1 with 100 and show 2 with 200. So let's just have a look at that. Create your change test reference. So that gives you a CT reference referring to a change test object. And we have a my value of 0. Okay, that's what that does there. Then we come along, we call show1 passing in 100. So we're calling an instance method using the reference, good. Show1, there's the my value, so that becomes 100. And we say my value sign my value. That's hiding, shadowing. That's shadowing. So the my value there is shadowing the my value up here. And all you're doing is you're just assigning the local variable to itself again. And then when we output this dot my value, we're referring to what is the value of the instance variable, and that's 0. So you're going to get 0 output. Come back down here and we call the show2 method passing in 200. 200 comes into my value. And now we change the instance variable to be whatever's in my value, which is 200. So that becomes 200 there. Okay. And then we output this dot my value. So that's 200. So the answer is the third one, 0 followed by 200. Okay. And I'll just load up the next one right here because it's actually quite similar. Okay, this particular one. So we create change test referring to an object and it's 0. And then we've got show1 with 100. Okay. So CT is a reference to our change test. I've got a my value 0. Now, we then come along and we call the show1 with 100. There it is. And that's shadowing it. My value and my value, we're doing nothing. So we output that and it's going to be 0. Then we go along and we call show2 with 200. There's the 200 coming into my value. And then we say the instance variable is assigned 200. Therefore, we go and we output 200. Okay, this particular one, 924, we are calling, we've got a test class with a probe which takes an integer, and then we have a probe which takes an object, and we have a probe method which takes a long. They are all overloaded. Same method names, different argument types. So the compiler has no problem figuring out which one you're calling. However, here's a string, and then we call new test class again, instance methods. If you're going to call them from main, make sure you have a reference to the current class, test class. Passing, calling in probe, passing in a string. So the question is, which one will it go into? There is no string there. Is it going to give you a compiler error, or will it go into integer, object, or long? And the answer is, because the string is an object, is that it'll go into object. It'll upcast and go in there.